Hello everybody, my name is Ashley Sue, and today I will be presenting our paper titled Are Metrics Enough? Guidelines for Communicating and Visualizing Predictive Models to Subject Matter Experts. We know that the use of AI has exploded into the mainstream. In fact, between 2018 and 2020, the percentage of firms investing at least $50 million into AI increased by 63%. However, despite these increased investments in AI, only 15% of these firms reported that they had actually deployed AI capabilities into widespread production. Similar findings were echoed by a 2020 MIT SMR report, stating that 7 out of 10 companies reported minimal to no impact from their organization's AI use. And only 10% of these companies reported any significant financial benefits from implementing AI. Now, after reading through countless findings like these, it became evident to me that there exists a clear gap between the promise and the actual execution of these AI and ML models in practice. So, what's the problem? Time and time again, strained communication between data scientists and subject matter experts is cited as a top barrier in collaborations, ultimately preventing model use and deployment. Of course, there are many factors that prevent model deployment and burden collaborations, but for the purpose of this talk, I'm going to focus on the strained communication. A quote by Scott Barrento, a visualization consultant and senior editor at HBR, illustrates this. He says, "In my work, I hear both data scientists and executives vent their frustration. Data teams know they're sitting on valuable insights but can't sell them. Executives, meanwhile, don't see tangible results because the results aren't communicated in their language." Now, it seems obvious that we would use visualization as a medium to facilitate communication during AI and ML collaborations. However, many of the AI and ML visualization solutions that are used today focus on helping data scientists, or those that we consider ML experts. Moreover, common visualizations used to communicate model performance aren't easily interpretable to SMEs. These visualizations can leave SMEs wondering, what about my use case? Or how do these actually depict the model's weakness? Therefore, the question we would like to answer is, how do we best communicate the whole story of a predictive model to subject matter experts who ultimately decide what to do with it? To address this question, we conducted an interview study with 7 data scientists and 6 subject matter experts working in the same organization. The goals of our study were to understand the types of barriers that data scientists and SMEs face when assessing models, investigate if any current visualizations or communication styles do or don't work well, and finally, determine best practices to facilitate communication between the two groups. We interviewed a total of 13 participants in one-on-one interviews lasting roughly 1 hour each. Participants were required to have familiarity with regression modeling as a baseline for our interview study. SMEs were selected based on having expertise in a field outside of data science, but they were required to have at least some experience working with the outputs of a regression model. Participants were walked through 3 modeling scenarios totaling 3 main interview topics discussed in our study. The first topic related to what the participant would need to know about a regression model before recommending its use. The second topic related to how the participant had assessed and communicated a regression model in their workplace previously. And finally, the last topic covered how communicating a regression model's performance with data scientists and SMEs could be improved during collaborations. Following these interviews, we conducted a thematic analysis of our interview data to understand key challenges faced by data scientists and SMEs, as well as practices that have worked well in the past for them. We ended up with 3 overarching themes, the first being presentation and visualization style, the second, understanding model strengths and weaknesses, and the third, gaps in language, context, and comfort. I'll now briefly discuss some of the key findings from our qualitative analysis. In general, we found that metrics and visuals provide little insight to SMEs without proper explanation, context, and rationale from data scientists. One SME told us that data scientists need to explain what the metrics mean, so we're able to relate the results to the context that we're working in. Another SME told us that she has noticed a great deal of skepticism surrounding the use of metrics by data scientists. Throughout our interviews, we found time and time again that SMEs stress the importance of knowing exactly when, where, how, and why a model might fail. One SME stressed to us, if we're using this model and there's something wrong with it, there are consequences to that decision. There's a human being at the end of it. That's why I'd want as much information about the model as possible. So if I'm going to make a decision about applying this in the real world, then at least I know exactly what its limitations are. We also found that overly technical presentations, as well as the perceived aloofness of data scientists, discourage SMEs from asking questions. One SME revealed to us that sometimes these data science presentations just go over your head, and I think the end user, a good chunk of the time, would be too embarrassed to say, I don't get what you're talking about. From the analysis of our interviews, we distilled a set of communication and visualization guidelines that can begin to alleviate many of the challenges identified in our study. The first three guidelines relate to presentation and visualization styles. Provide context for a model's performance by annotating plots with clear stories. For any chart that communicates a model's performance, provide a range of comparisons. Visually explain the significance of aggregated metrics. The next three guidelines relate to communicating a model's strengths and weaknesses. Point to outliers in the model's performance and data space with known or plausible explanations. Explicitly describe the data used in training and testing a model, any pre-processing or transformations performed, and provide examples. Communicate the limitations, weaknesses, and blind spots of the model, especially when suggesting it can replace the existing solutions. The last three guidelines relate to the language used by both groups and promoting context and comfort during presentations. When articulating results, start slow and offer to speed up. Use visualization as a medium when appropriate. Provide a pre-read document or appendix with explanations and illustrations of any models, metrics, or unfamiliar vocabulary. Tie in use cases for the model by illustrating real-life, objective-driven examples. Although I've listed all of our guidelines here, there are many more details and examples that can be found in our paper, beyond these simple taglines that I've shared. Following our first set of interviews, we conducted a second round of interviews with the SMEs of the original study. Our goal was to understand which of our guidelines are most and least effective and why. To do so, we walked SMEs through two different data science presentations on two different modeling scenarios. The first without the guidelines, following common data science practices, and the second with our guidelines. For these follow-up interviews, we created 4 visualizations based on the guidelines. The first visualization is a paired heat map by error category with a feature distribution. The second is a correlation scatter plot with a confidence ellipse depicting the R-squared metric visually. The third is a pair of histograms representing predicted values versus actual values. And the fourth is a bar chart with a highlighted global error line. We also included other presentation elements that were mapped from our guidelines. This included a slide encouraging participants to stop us for clarifying questions, a slide detailing the data in plain English, a slide describing metrics, how they're calculated, and what a low or high score means, and a slide with explicit examples of a model performing poorly with annotated explanations for why we thought this poor performance was happening. I'll now briefly discuss some takeaways from our follow-up interviews, but again, I will refer to the paper for full details. First, we found that highlighting the model's weaknesses informs decision-making and boosts credibility. Defining data science terminology, model differences, and error metrics establishes a common framework. And encouraging SMEs to ask for clarification helps the presentation feel like an exchange rather than an exam. As far as visualization takeaways, we found that visual comparisons that tell a clear story are preferred to simple text and metrics. Importantly, SMEs pointed out with the supplied visualizations and annotations, they had quick or instant insights that they otherwise would not have had without them. In terms of how helpful each of the visualizations were in increasing the SME's understanding of a model's performance, our heat map performed the best, the correlation scatter plot second, the paired histograms third, and the global error bar chart last. The full feedback from SMEs is available in our paper. This includes additional quotes and extensive details on the protocol for our follow-up study. Our slides presented to SMEs are also included in our supplemental materials. In summary, our results indicated that our guidelines are helpful in producing a better understanding in SMEs of the nuances of a model's performance, including its strengths, weaknesses, and trade-offs, beyond text, numbers, and commonly used model metrics. That concludes my talk. For all of our study materials, including the slides presented to SMEs in both interview studies, please visit our GitHub page. For an interactive observable notebook with all the visualizations used in this study and their interactive versions, please visit our observable page. Thank you.